Welcome to Distributed Database Management System. Today we will discuss about problem areas in distributed DBMS. In previous lecture, we have covered up promises of DDBMS. Three promises we have studied. First one is a transparent management of distributed and replicated data, then reliability through distributed transaction, and third one is a improved performance. In first, transparent management of distributed and replicated data, we have understand the concept of transparency. There is 5 transparency concept. First, distribution of data, data independence, network transparency, replication of data, and fragmentation transparency. In transparency, we have also covered the layer of transparency through which user can communicate with our database. Then second promise is related to reliability, distributed transaction, consistency, performance improvement, and complication. These things we have covered up. The performance improvement means improved performance is also one of the concept of promises of DDBMS. Means it's a improved performance and last complication factor. So this is all about the promises of DDBMS. Now we will move forward with the problem areas, and that is the last point of our Unit 1 introduction of Distributed Database Management System. There is total number of 9 problem areas we have to study in this video lecture. First one is a distributed database design. Then second one is a distributed query processing. Third one is a distributed directory management. Fourth one is a distributed concurrency control. Fifth, distributed deadlock management. Sixth, reliability of distributed DBMS. Seventh, operating system support. 8, heterogeneous database. And last one, the point 9 is relationship among the problems. In 9 point we will discuss about the entire 8-point relation. The problem 1 will have effect to problem 2, 3, 4, means all the problem are related with each other. So this problem we will going to discuss in this video lecture. So let's start in detail the distributed DBMS problem areas. First problem is distributed database design. Always the question that is being addressed is how the database and the application that run it should be placed across the site. There are 2 basic alternatives to placing data. First one is a partition. It is also known as a non-replicated, and the second alternative is replicated. In the partition scheme, the database is divided into a number of disjoint partitions, each of which is placed at a different site. And in a replicated design can be either fully replicated, also known as a fully duplicated, where the entire database is stored at each site, or partially replicated, means it is also called as a partially duplicated, where each partition of the database is stored at more than one site, but not at all the sites. Here the 2 fundamental design issues are fragmentation, the separation of the database into partitions called fragments, and distribution, the optimum distribution of fragments. So it's a first problem of distributed because if database design is not done properly and in proper manner, then storing or retrieving data from distributed DBMS or distributed database, it will give you the wrong output and complexity can be generated. And the main aim of the database is to minimize cost. With that we can retrieve and store data in our database. But the base fundamental is that the database design must be proper so that we can store and retrieve our data effectively. So for database design purpose, there is some of the alternatives to placing the data which we have discussed, in which partition, also known as a non-replicated, means in a partition we have to divide our database in a small fragment. We have to partition our database in a small part, but it also known as a non-replicated, because the replicated name suggests that we are going to create the duplicate copy of that database, so it's known as a replicated data. In replication there is also two procedures: fully replicated, in which database is stored at each site, but here the entire database is stored at each site, because then and then it will known as a fully replicated. Whereas in a partially replicated, entire database will be divided at different sites with each it's a partition. So first problem is a distributed database design. Then after, second one is a distributed query processing. Query processing deal with designing algorithm that analyze query and convert them into a series of data manipulation operation. The problem is how to decide on a strategy for executing each query over the network in the most cost-effective way, however cost is defined. The factors to be considered are the distribution of data, communication cost, and lack of sufficient locally available information. Our overall objective is to optimize where the inherent parallelism is used to improve the performance. In previous lecture, improved performance, we have discussed inherent parallelism, in which interquery and intraquery things we have discussed. So in a distributed query processing problem, if we are failed to optimize the query and if we are failed to provide the strategic execution of each and every query over the network, then it will give us the not proper output as we want. So cost factor is again the point over here in a query processing, and optimization process will be play its role. But again, when the problem create at the time which we are not implementing such a things in a proper manner, that time problem areas will occur. Then third problem areas is directory management. There are three levels of directories: conceptual, logical, and physical. A conceptual data model identifies the highest level relationship between the different entities or different tables. A logical data model describes the data in as much detail as possible without to how they will be physically implemented in the database. And last, physical, in which they are give you the physical information about your data. A directory contains information like description and location about data item in a database. Means with the help of directory management you can get the information about database or information about data items which is stored in your database. Problems related to directory management are simple in nature, in which a directory may be global to the entire DDBMS or local to each site. It can be centralized at one site or distributed over several sites. There can be a single copy or multiple copy. As the name suggests, directory management, in which we have to maintain the information of our data item which store in database, and also give the simple example that in your project you are going to make the data dictionary. So it's nothing but a collection of your table in which you will specify that total number of column, its constraint, its data type, size, which field will store which type of value. So such kind of will work with directory management. So directory entries, and from the directory, if you are not able to get the information properly or correct information of your data item, then it will generate the problems for that. Then after, concurrency control. Concurrency control, the name suggests concurrency. So here we are going to understand or classify that concurrency means concurrent execution of your data. Concurrency control involves the synchronization of accesses to the distributed database such that the integrity of the database is maintained. The concurrency control problem in a distributed point of view is somewhat different than in a centralized framework. One not only has to worry about the integrity of single database, but also about the consistency of multiple copies of the database, because in a distributed there is a multiple copies of database is available in a network. So all the copies consistency we have to maintain. The condition that require all the value of multiple copies of every data item to be maintained to the same value is called mutual consistency. So with the help of all the database and with the help of all the copies, mutually we have to maintain the consistency of our entire data system or entire network of the distributed database management system. When multiple procedures are going to perform on our database, at that time problem will generate. For the solution purpose or alternative solution, there is a two general classes are. First one is a pessimistic and second one is a optimistic. In a pessimistic, synchronizing the execution of user request before the execution start. Here you have to understand the line or sentence, synchronizing the execution of user request before the execution start. So here user request will be executed or will be synchronized before our final or our execution of data start. And in a optimistic, executing the request first and then checking if the execution compromised and maintain the consistency of database or not. So this is the concept of pessimistic and optimistic. And one more, there is two fundamental primitives that can be used with both approaches are locking and time stamping. Locking, which is based on the mutual exclusion of access of data item, and it related with the deadlock. When we are using the locking concept, at that time it may be generate deadlock in our database system or our in network. And the second one is a time stamping, where the transactions are executed in some order And if we are combining this both concept, then with the help of hybrid algorithm we can apply the concept that will be cover up later on in further syllabus hybrid algorithm, but just for the point or not, you have to remember right now only the name of it. After that, distributed deadlock management. The deadlock problem in DDBMS is similar as we learn in a operating system. The competing among user for accessing to a set of resources can result in a deadlock if the synchronization mechanism is based on locking. Here we are using the word data in place of resources because in a distributed database management system we are dealing with the data. So if number of user will access set of data, that can result in the point of deadlock. The well-known alternative solution for this problem is a prevention, avoidance and detection or recovery. So deadlock is also one of the problem which will disturb our execution or accessing or storing the data in a distributed database management system. Then after next is reliability. There is 2 points we have to discuss: how to make the system resilient to failure and atomicity and durability. Atomicity and durability is the property of asset property in which atomicity 100% transaction must be complete or otherwise 100% it will be recover or in a consistent state. Durability, if transaction fail due to the system failure, then it contain its last consistent state output. And first point, how to make a system resilient to failure. We have to make such kind of fundamental or such kind of function so that we are preventing our system from the failure. We mentioned earlier that one of the potential advantage of distributed system is to improve reliability and availability, but it is not automatically implemented over here. It is important that mechanism be provided to ensure the consistency of the database as well as to detect failure and recover from them. The implication of DDBMS is that when a failure occurs and various sites become either inoperable or inaccessible, the database at the operational site remain consistent and up to date. Furthermore, when the computer system or network recover from the failure, the DDBMS should be able to recover and bring the database at the failed site up to date. So, to provide the reliability in a distributed DBMS is one of the complicated or difficult tasks because it's connected in the network where the sites are divided into 2 or more groups. So, it will generate the problem when some of the portion of database or some of the site or database are inaccessible or it will not in our communication, then this kind of problem will play its role. But then also we are going to our best to give us reliability to our user in a distributed DBMS. Now next is the operating system support. The current implementation of distributed database system on top or under the conventional operating system suffer from the performance bottleneck. If throughout we are performing and accessing the data in a fast manner, then bottleneck problem will generate or performance may down. The bottleneck we have already understand in our previous lecture. The support provided by operating system for database operation does not correspond properly to the requirement of database management software. The major operating system related problem in a single processor system are memory management, file system and access method or crash recovery and process management. So the finding solution is divided into two groups, where we are going to provide general purpose processing requirement and database processing requirement. So here we are going to provide a simple support for distributed database operation and as well as providing the general operating system support for the application. So we can solve out this issue related to the operating system, and this problem will generate at the time where the operating system not responding properly based on our requirement and based on our request. So it's all about the operating system. Then after, heterogeneous database, sometimes it also known as a multi-database. Then what is the meaning of heterogeneous? Heterogeneous is the opposite of homogeneous or homogeneity, where homogeneous means similar kind of data, where heterogeneous means it does not contain similarity, where there is no homogeneity among the database at various sites, either in terms of the way data is logically structured or in terms of the mechanism provided for accessing it. It becomes necessary to provide a translation mechanism between database system. This translation mechanism usually involves a canonical form to facilitate data translation as well as program template for translating data manipulation instruction. In terms of that, if one is constructing a distributed DBMS from a number of autonomous centralized DBMS, in this setting the problem are more general than heterogeneity. In fact, such a system is also known as a multi-database system, as our point 1 I have told you that. This should be considered as a complementary to the distributed DBMS as defined over here. Why this heterogeneous problem generated in distributed DBMS? Because if some of the database is already exist but it's not known by the user, that time it will generate the problem, because all the different data placed at different site and user don't know which data is stored over which place. So here we have to include some of the accepted form of facility of data translation, so that the data manipulation instruction and translation mechanism can work effectively on database system. And now last point is a relationship between issues. So in the diagram you can see all the problem areas we have discussed previously. First, we are going to start from the distributed database design. Here it might be possible to characterize the effect of one problem on another problem through the use of parameter and constraint. In fact, each problem is affected by the solution found for the other, and in turn affect the set of feasible solution for them. So in this section we discuss how they are related. The relationship among the component So here in the figure, the design of distributed database affect many areas. It affects directory management because the definition of fragments and their placement determine the content of the directory, as well as the strategy that may be employed to manage them. The same information is used by the query processor to determine the query evaluation strategy. On the other hand, the access and usage pattern that are determine the query processing are used as an input to the data distribution and fragmentation algorithm. Similarly, directory placement and content will disturb the processing of queries. The replication of fragments when they are distributed affect the concurrency control strategy that might be employed. Some of the concurrency control algorithm cannot be easily used with replicated data. Similarly, usage and access pattern to the database will influence the concurrency control algorithm. If the environment is updated, then intents of necessary precaution are quite different from those in query only environment. Here you can see the figure. Distributed DBMS or database design will affect directory management as well as concurrency control, and directory management will be effect on query processing, also in reliability of our database, and then after concurrency through deadlock management. There is a strong relationship among the concurrency control problem, the deadlock management problem, and reliability issue. This is to be accepted since together they are usually called the transaction management problem. The concurrency control algorithm that is employed will determine whether or not a separate deadlock management facility is required. If a locking based algorithm is used, deadlock will occur, where they will not if timestamping is the chosen alternative. Reliability mechanisms are implemented on the top of concurrency control algorithm. Therefore, the relationship among them is self-explanatory. It should be also mentioned that the reliability mechanism being considered have an effect on the choice of the concurrency control algorithm. So these are the entire relationship between our problem issues. They are affect each and every one. So I think you will understand the problem areas from this video lecture. Again, there are 9 problem areas. First, database design, query processing, directory management, concurrency control, deadlock management, distributed DBMS. But here the point is reliability of distributed management system, operating system, heterogeneous database, and last, the relationship among our all this problem issue. So it's all about our Unit 1 Introduction to Database Management System. Thank you for watching this video.